On this episode of Curve Ahead, I am joined by Jason Cortez, a transportation and energy infrastructure veteran, and now the VP of EV services at Field Advantage, a company keeping EV charging infrastructure running nationwide. Jason brings a unique insider's perspective, having gone from being a Field Advantage customer to leading their EV division. In this episode, we cover why EV chargers aren't set it and forget it assets, but smart connected machines that need upkeep. We also touched on common misconceptions about EV charging, from inconvenience to battery fires, and why 70% of charging actually happens at home. If you're curious how EV charging actually works, or how policies, reliability, and consumer trust are shaping the future of mobility, this one's packed with practical insights. This episode of Curve Ahead is brought to you by Atozi, the podcasting agency helping amplify your brand's voice. Hey, Jason, welcome to the podcast. Do you mind introducing yourself?
Yeah, thanks for the invite, Brian. I appreciate the opportunity to be part of the Curve Ahead conversation. So, Jason Cortez, based in San Antonio, Texas. I've spent 27 years in transportation and energy infrastructure. On the energy infrastructure side, I started out in downstream oil and gas at the fuel retailer level. So I've worked for several companies that design and build and service gas stations and commercial and industrial refueling centers. And around 2016, 2017, I moved over to advancing e-mobility. E-mobility is basically the transportation of people and goods in vehicles powered by electrons versus petroleum. So electric vehicles, as we all refer to them as. I've been on the front lines of deploying national EV charging infrastructure. And so I've kind of worked throughout the value chain. I've worked for installers, I've worked for EV charger manufacturers and EV charger service providers, and roles, and like I say, across the value chain, business development, operations, go-to-market strategy, so forth.
So tell me what led you to Field Advantage and where you're at now. How did your background lead you to there?
Cool thing about my story with Field Advantage is that I was a customer of Field Advantage before I was an employee. I had been working for a leading manufacturer of chargers, and Field Advantage was providing their field services. Field Advantage was and continues to solve a real pain point in the industry, and that pain point is the disconnect between charging infrastructure that works and the reality of keeping it running in the field. So Field Advantage has technicians deployed across the U.S. working on various IoT assets, and I had a working relationship with them. And when the invitation was made to come over and lead our EV business unit, I didn't hesitate.
So, in a nutshell, tell me more specifically what it is that you're responsible for. Are you responsible for the infrastructure and supporting it and the techs that are out in the field? Give me a high level there.
Yeah. So when you look at the overall infrastructure of a charging destination, whether it's publicly accessible in a retail context or it's used for fleets, you have, of course, upstream infrastructure, i.e., electrical construction that leads down to the charger. And then you have the charger, of course, or the chargers. And these chargers could be DC fast chargers, which are, all kinds of levels of output, as low as 50 kilowatts, as high as 400 kilowatts. And then, of course, you have AC charging, which is a lower time field type of charging experience. But the infrastructure that Field Advantage supports is really at the charger, both on hardware and software. And so when you start thinking about the transformers and switchgear and all the service disconnect, everything that's kind of upstream that electricians install and general contractors install through electricians, that's not where we're working. We're actually working at the charger and on the software, keeping it operational.
So, is your job more hardware or software these days?
When you look at the EV charger, it is a IoT asset. It's literally a digitally connected asset. And so it's not just, hardware that's grid tied, that's dispensing electrons. It is communicating with the vehicle. So if I could use an example of petroleum fueling. So when you pull up to a gas pump, when you uncradle the nozzle and you stick it in the tank, you're dispensing petroleum product into a tank. That's what's happening. You're dumping fuel into your fuel tank. When a EV plugs into a EV charger, the charger is actually requesting energy. So the vehicle is in control of that charging session and is communicating. Its onboard battery management system is communicating not only its state of charge, but what it's going to take to get the amount of electrons it needs to be at the level that the driver has set that charger to. So as a general rule, most EVs are set to charge at 80% and then they stop. And that's really about preserving the life of and extending the longevity of the battery management system. But the reason I'm giving you all those details is because it's a little bit of it's a digitally connected asset. It's a smart device, and so it's not just a gas pump that is sucking fuel from a tank that's underground and pushing it into the tank of a vehicle. It is a communicating device with a intelligently communicating with the onboard system within the vehicle.
I mean, I think that you kind of painted a fantastic picture there that helps people who, like myself, don't have an EV better understand kind of that process, that handshake between the actual charging station, the physical plug that you're putting into your vehicle, and what your vehicle is telling back to that to be like, yes, okay, I'm ready to accept. I'm full, versus like a traditional gas pump.
When you pull up to a gas pump, your experience at the gas pump is 2 to 3 minutes. If you're there for 4 to 5 minutes, you're probably agitated. The customer that's fueling at the fuel pump that's going really slow, most gas pumps dispense at 22 to 25 gallons per minute. One of the misconceptions around EV charging, and maybe getting ahead of myself here because we probably will dive into this later in the conversation, but is the difference between charging and fueling. That's always been a rub point, especially for those that don't see EV as something that would work for them, because the concept around, well, charging is a different experience and it takes forever to charge a vehicle. And so, when a vehicle first plugs into a charger, it's going to communicate its state of charge, whether that's 15%, 80%, 50%, whatever it may be. And that charger is going to dispense, if we could call it that, a greater volume of electrons at the beginning. But of course, when you have a distribution of energy and a receptacle that's absorbing that energy, you've got heat and you've got other factors. And so the state of charge is going to dictate a quick charge at the beginning, but then the longer you charge and your state of charge increases, the output of the charger is going to reach. And so you use the term handshake, which is an appropriate way to reframe that, because the energy is going to start to dispense slower as those electrons are looking for a place to park, you might say, within the parking lot of the battery management system. The parking lot starts to fill up. So you think of a parking lot, it's empty at the beginning of the day, and then as cars begin to fill up, there's less spaces for those electrons, and so that's why it gets slower in the charging process towards the
I
end of
mean,
it.
you had touched on it, and it was obviously something on the agenda to talk about. What are some of the other common misconceptions about EV and EV infrastructure?
Brian, there's so many. There's a lot when you think about misconceptions. I mean, one is that EV charging is super inconvenient, and that's mainly because people compare it directly to the fuel pump experience, and that's fair enough because that's what we've known. We have 150 years of conditioning as consumers to how we get fuel, and so the first thing is that EV charging, when we look at fueling, i.e., petroleum fueling versus charging, they don't mirror each other, and they're not really intended to mirror each other. I don't know of anyone that has gas pumps at their home, but when you look at the EV driver, 70% of their charging occurs at their home, and that's usually overnight. And so the car's ready to go when you wake up, just like your cell phone. You plug it in at the end of the night, and it's going to charge, and it's ready to go in the morning when you wake up. So that's happening at home. Now, of course, there are some other aspects to where people live and access to charging. If you're in a multifamily community, if your community doesn't have a charger in it, then you're dependent on public charging, or perhaps you don't have the capacity from an electrical standpoint to put in a home charger. But as a general rule, most of the people that are investing in electric vehicles are investing in home charging. So they're doing 70% of their charging at home and 30% of the charging in the marketplace. Going back to the point about the inconvenience, or the idea that EV charging is inconvenient. You're charging at home. So I'm an EV driver. I have a gas powered vehicle and I have a EV as well. When I'm on a public charger, I'm not just sitting there waiting for the charging session. That time is being repurposed on other things. And so, and charging is the analogy of charging your car versus charging your phone only has so much distance it can go. Charging is an intentional experience. So I'm thinking about my charging needs based on the utilization of my vehicle. But the thing is charging doesn't catch me by surprise. And so I'm repurposing that time while I'm charging, doing other things. I'm answering emails, I'm hopping on work calls, I may be grabbing a bite to eat or walking through a store somewhere. Basically, it's all dependent on where I'm charging at in the public and what's around me in terms of amenities. And so the mind shift is that you charge while you're doing life, not pausing life to charge. And so that's one misconception. Another one that I hear about a lot, and there's a lot of clickbait to it as well, is around fires. People think EVs catch on fire all the time. And so the thing is it happens so infrequent that you always hear about it because it's clickbait. It's newsworthy. It's something that, hey, here's an emerging technology that's on fire, and what does that mean? And statistically, about there are 20 EVs on fire for every 100,000 EVs. But when you look at it from petroleum power, you compare that to 2,000 vehicular fires per 100,000 vehicles. So it's, EVs on fire are sensational, but they're clickbait, and it's a fear that doesn't really line up with the data. Yeah. I could also talk about perceptions around on the EV charger side. There's an idea that EV chargers are just kind of set it and forget about it. That's not the case. And that's why companies like Field Advantage exist, is because you can't set an EV charger because, like we talked about, what is an EV charger? It's a digitally connected asset. It's intelligent. It's communicating with the vehicle. And so you don't just set chargers and forget about them. They're high powered, software enabled machine that's sitting in public environments. And we know what the public does. There's high friction points around the charger, just like if you ever pulled up to a gas pump, the screen on the pump may be damaged. Someone may put a fuel nozzle into the vehicle and then drive off and take the nozzle with them. So it's a long way of saying chargers need upkeep, and they need preventative and corrective maintenance. And so they're just like any other critical infrastructure. And that's why Field Advantage exists, is to keep them running.
I think that was an interesting point that you made in there. Well, two of them. One, that 70% of charging happens at home, whereas like with traditional fueling, you actually have to take time out of your day to do it. From like an infrastructure perspective, knowing that only 70% of like fueling happens away from the house, how has the infrastructure adopted to that, and where are you seeing more charging stations going in, not necessarily at traditional fueling type stations, like what does that trend there look like? Does that line of questioning make sense to you? Okay.
It does. And, when you look at EV charging infrastructure as it is today, there's one perspective around that. But let's go back 10 years, and so Tesla is a citable EV. Went public in 2013, I believe it was. They had to have a charging infrastructure to support their core product, which was the vehicle. Tesla didn't come into the public domain with the intent to provide chargers. It came into the marketplace with a vehicle. And so they needed that charging infrastructure to support their core product. Yes, some of those vehicle purchases were also including level 2 or home-based charging. And so we have Tesla to thank for the amount of charging points that are out there in the market today. But again, they brought to market a charging infrastructure that was supportive of their product. It's only been within the last year and a half or so that they began to open up their network to other OEMs. And so that's one aspect of it. So that kind of gets us from like 2013, 2014 to today. Now, when we look at where chargers are today, I as an EV driver, I'm kind of like with my gas powered vehicle. I don't really worry where gas pumps are because I know I can drive in any given direction. I'm going to find a gas station. For someone that's not driven an EV, they don't have that perspective. They perhaps have never see chargers apart from the Tesla chargers that they see in different places. And so chargers are everywhere. They're in all sectors. They're in retail and commercial property. There's hospitality industries that have chargers. Convenience store, gas gas stations. Actually, that's where I started out trying to market. I mean, you can imagine what it was like in 2016. Here I am. I'm already working within the downstream oil and gas world, working with petroleum retailers. And in 2016, 2017, I'm trying to get them to invest in EV charging, and they're looking like that. Hey, that's a competitive product. That's not what we do. We're a company. Why in the world would we invest in EV chargers? But yet now there are petroleum retailers with chargers. And so, kind of bringing this back in to answer your question. So now chargers are in all kinds of verticals, and there's an industry term. The acronym is CPO or CSO, and that CSO stands for charge station operator. CPO stands for charge point operator. Those are synonymous terms, and basically what they mean is those are owner operators of chargers. So you could say they're like the gas station of the EV sector, if I could frame it that way. And so lots of companies are either site host to CPOs/CESOs, or they themselves have invested in infrastructure. They've paid to have a portion of their real estate electrified, and now they are hosting chargers.
So let's dig into that a little bit further. So what is it like to partner with these organizations to make sure that they have the continuity of service at their stations for the public?
Yep. That's a good question, and so that's what one of the things Field Advantage does is we're partnering really with the manufacturers of the chargers, but we also are partnering with the CPOs or CSOs, and I think so. I don't keep referring to them in both terms. I'm just going to call them CPOs for the duration of our conversation. So we are partnering directly with the manufacturer, and then we are also partnering with the CPO. And so from a manufacturing side, we'll call those that are building and designing and distributing chargers, we'll call them OEMs. So those are the manufacturers of the chargers. The OEMs care about efficiencies and technical support and supporting their warranty or service level agreement products. So that's how they build this product. And there's 30 to 40 manufacturers in the United States. And they are designing these chargers and they're moving them into the market through distribution channels, through value added resellers, or they're selling directly to these CPOs. And so these OEMs, they care about how the product is supported and how they undergird that warranty that kind of creates value. And then the CPO is focused on uptime. They're focused on driver experience, but both of them care about their brand reputation. The OEM wants to have a solid product that stays working, and the CPO wants to make sure that their charging device is working for their customers. Because see, when you look at the CPO, they've got a direct income at the charger, but they also have an indirect income and an increase in that indirect income of having those chargers. So let's say you're a hotel, you own chargers as well, and they're in your parking lots. Technically, you're like a CPO, and you have them as an additional amenity to draw in the EV driver to stay at your hotel versus the other hotel across the street that doesn't have it. And so uptime is important to you because I'm an EV driver myself. I pick the hotel that has the charger if I'm driving to that hotel. And so if their charger isn't working, well, we're already starting off the experience on a negative light in a negative light. And so, it's a long way of saying the OEM, the CPO both care about their brand reputation. And then when you kind of get out of that public charging context, you think about the fleets. The fleets are all about speed. They're all about predictability, minimal downtime. Their fleet is mission critical, and so if they can't charge, they can't deliver their product. They can't meet that last mile delivery or whatever it is. So we have built a service solution that meets the needs of the OEM, that meets the needs of the CPO and the fleets as well. And so we kind of tailor our service solutions around those specific needs. And it's the same core field capabilities, the same core competencies, but with a different workflow and service level depending on who we're supporting.
So let's go back to two things that you had mentioned previously. One, you had mentioned with regards to, say, Tesla being one of the leaders in creating the infrastructure to have charging ports available to the public in a lot of public places, but not necessarily allowing other types of vehicles to charge at their stations. You also had mentioned that there's 40 or so other manufacturers of chargers. So let's talk about something like standardization. Like, where is the EV industry when it comes to standardization of charging ports and any of the other things that are just not quite there, or other common misconceptions that say I don't have an EV? Like, what am I not understanding here?
Yeah. It's a good question. And when you think about, whatever vehicle you drive, whether it's a Ford or a Chevrolet, you don't have a particular gas pump that you have to use for that manufacturer of charger. That's not the case in EV charging. We'll start with Tesla. Tesla brought to market a vehicle and a charging infrastructure to support that product, that vehicle. The connection or the handshake between that EV and that charger was proprietary, even not only from a communication protocol standpoint, but literally from how it plugs into the cars is unique to that vehicle. And so, as other charger manufacturers came to market, of course, they were bringing to market a product that wasn't proprietary, but yet they had to have a plug that would work on all EVs. And that's just not the case. So there's adapters that were introduced in kind of the value chain. So you've got adapters and you've got different plugs, but to kind of lasso all this in, bring it in on the market right now within a light duty vehicle context, a consumer passenger vehicle, you have three types of communication protocols which have unique hardware aspect to them. So Tesla has its own proprietary plug, and that's referred to as J400 or NACS. The American and European models of EVs, they have a plug that is referred to in the United States as CCS1. CCS1 simply stands for Combined Charging Standard. And then there's an outlier, a third protocol with its own unique hardware design, and that is a CHAdeMO. And that's CHAdeMO really is kind of limited to an Asian model of vehicle, and I think Mitsubishi. So that is kind of being phased out through attrition and through changes in technology. But for the most part, you have two different types of hardware and communication protocols, Teslas and CCS1. And so on the charger, you will typically have, whether it's a native plug for Tesla or access for a Tesla to that non-Tesla charger through an adapter, and then of course a CCS1. And so those are some variances in the technology. That's not something you experience in gas fueling. You just pull up to the gas pump and you dispense in gas or diesel, whatever your vehicle's powered by. And so again, all of that goes back to that handshake between the EV and the EV charger. They're speaking their own language essentially through that communication protocol.
Is the non-standardization an issue or an opportunity?
Good question. I'd probably say it's both. There are some limitations around output. So let me share one of those with you that really creates both a barrier and an opportunity. So a Tesla pulls up to a non-Tesla charger. They're going to need an adapter. That adapter plugs in to the Tesla, and the end of the cable on the non-Tesla charger plugs into the other end, and there is that handshake. There's a translation, you might say, through that adapter, and so it starts charging. Well, typically that charging experience is whether the output of the charger may be, let's just say, 240 kilowatts because of that adapter, because of that heat transference that I referred to, because of the communication protocol. There's a limiting or a derating of that power. So you've got this Tesla that could probably charge at 250 or 240 kilowatts. So you've got the charger that can charge at 240, but you've introduced this connector, which is limiting that power because of those factors that I just referred to, heat, communication protocols, et cetera. And so now it's limited to 150 kilowatts. Well, remember I talked about earlier in our conversation about state of charge and the length of time to charge and et cetera. Well, now you've you've increased your charging time at that session. So that's an opportunity for someone to create an adapter that can go higher, that will allow a higher output of 150. But it's also a problem because now the Tesla driver is kind of being penalized for not using a Tesla charger and using a third party charger. So that's one example. And there's a host of others that you could just kind of look at about the nuances versus universality, one plug, one charger, one receptacle on a vehicle, and it all works as easy as it does with petroleum fueling.
So let's switch up topics a little bit and talk about some of the trends in the industry. I know that EV is such a polarizing thing, or it can be. How does government policy impact the work that you're able to do and achieve?
It's a good question and insightful question, and you're absolutely right. Government policy and policy in general creates tailwinds and roadblocks and opportunities. One of the things that some have considered unfair with, regardless of what perspective you're looking at, is that here you have this emerging technology that now has all these funding opportunities associated with it. And so, the government, i.e., the government's paying for these chargers. Well, the government's not paying for fuel pumps and fuel gas stations to be put in. That's funded through private, through private business. And so, why is there public funds available? And we could dedicate a whole episode to talking about funding opportunities. And it's not just at the federal level. There are states that have funding opportunities. There are utilities that incentivize businesses to put in chargers, because what is their incentive as a utility? Well, now they're selling more electrons, so they incentivize businesses to put in chargers through subsidizing installation costs, or offsetting energy use, or time of use programs that reduce charges around electricity costs, et cetera. But going back to your original point, how does government policy impact this industry and in the work we do? And as I said, policy creates tailwinds, it creates roadblocks, creates opportunities. And we saw one immediate change with President Trump. He halted a national EV charging funding program. In our industry, we refer to it as NEVI, and NEVI is simply an acronym that stands for National Electric Vehicle Infrastructure. And it was funded through a bipartisan bill, and brought millions of dollars that would be allocated to each state to use for charging infrastructure. Now, it's distributed through a competitive application process. So we'll use my state. I live in Texas. Texas was allocated, call it $410 million. And so it was introduced. Our clean energy division within our state was the steward of that. And the name of that agency is slipping my mind. But essentially, that environment, Texas and Quality Environmental, TCEQ, I believe, and I may be off. But either way, we have a state agency. They're the steward of the funding. The funds are made available to the public businesses through a competitive application. You apply for it. Now, it's not covering 100% of the project costs. You have to fund all of it up front, and then you're reimbursed up to 80% of that. So each state got an allocation of funds to deploy chargers. President Trump came into office, and he halted that program. And so when you start talking about free money, and that's a drag in deployments, and I've been of the opinion that when it comes to public funding made available through a competitive application process for business to apply for funds, and then they can put in chargers, and there's free money. I've been in this industry for 8 years, and I have only viewed free money as a drag in deployments, because it creates interested parties that aren't really viable candidates to deploy chargers in the first place. It's like, hey, I can make a quick buck in this EV game. Well, there's no quick bucks in the EV industry, none at all. It's and so all the public funding programs, they may face reductions, and in my opinion, it's probably for the better, because it can weed out projects that are dependent on subsidies, and then developers instead, they can focus on private funding avenues, and structuring viable products, and then let the market sort out the financials. That's what I feel about it. I think the market should sort out the financials, and the only government, going back to government policy, when we look at a fueling destination, it's typically regulated. A retail fuel gas pump is regulated through weights and measures. And so you as a consumer, you pull up, you're buying 22 gallons of gas, you get 22 gallons of gas. And we know that because the state has mandated that pump be checked for calibration, and it's dispensing what you're paying for. And so I think that should be the same thing. I say, let the market set out the financials, and let government policy provide a limited regulation, like it does with petroleum fueling, i.e., where you can put the chargers, what the price points should be, et cetera.
On a flip side of that, right? And I'm not trying to have us get into this discussion, but I know that you and I had talked about this previously, is that part of the price of fuel is taxes, and those taxes go to maintaining infrastructure like roads and bridges and stuff like that. How does that differ for EV?
Good question, and that's a good call out. So every time you buy a gallon of gas, there's an allocation of that, whether it's for, $3 or $2 or wherever you're at in your state, whatever you're paying for, there's an allocation of that cost per gallon that's associated for road tax and keeping the infrastructure maintained. Drivers aren't paying that because they're not buying gas. and the EVs themselves are heavier. So they're not contributing to the infrastructure through buying gas, and their vehicles are heavier, so they're tearing up the infrastructure. So states kind of had to evaluate a way to recoup that and a way for the EV driver to contribute that. And so some have implemented a cost attached to the registration. So I'll use my state again as an example. When you buy an electric vehicle in Texas, on the front end, you're going to pay $400 to register that vehicle. And then when it comes time to renew your registration, in the state of Texas, you're going to pay $200. And so, I have an SUV for my gas vehicle. I think registration costs for that vehicle are 70, $80, something like that. For an EV, it's going to be $200. And that additional funding attached to the vehicle registration is a way to recoup those costs not paid for, I guess you could say, to contribute to the infrastructure, et cetera, at the gas pump. And so, is it fair? Does it balance out? Depends on who you ask. For those that don't like it, don't want to pay a $200 registration fee, they'll find ways to disagree with it. I think regardless, you gotta give back in one way or another.
All right, so let's change it up a little bit, and let's talk about what is the biggest challenge that you face in Field Advantage in the coming 2025, 2026 calendar years, and how are you planning to overcome it?
Yeah. Scale without compromising quality. Obviously, we've got X amount of technicians across the U.S. Field Advantage. So, kind of going back to what we do, EV charger servicing isn't all we do as a company. We are servicing all digitally connected assets. So we have 2,000 technicians across the United States working on anything that's digitally connected. IoT asset could be a camera, could be a point of sale system, could be anything. But anyways, when it gets down to chargers, there's specialized training attached to that. So with the manufacturer, and some of that training at the manufacturer level tends to be myopic to their product. So, we'll say we're doing work for charger manufacturer A, and their, SOP around how you replace this particular device that's also on charger B could be a completely different SOP. So, when it gets down to scale without compromising quality, we've got to make sure we've got technicians available that we can invest in that can work on the chargers. As more chargers hit the ground, the pressure on field service providers will grow. And, our plan is to stay disciplined, to invest in training, to invest in technology, to invest in and refine and continue to refine our process. We're scaling smart, not just scaling fast. It's about capacity and quality as a balance. And so, we're also having to navigate how we partner. There's been different players within the space, both on the manufacturing and CPO side, that have come to market, and they've been stable. But because this is an unstable market, it's emerging technology, it's a competitive space. There's at times very razor thin margins. There's all kinds of factors that players will disappear from the scene. And so we've got to stay agile, and we've also got to stay kind of agnostic towards whatever comes to market. We've got to be ready to work on it. We'll be trained and certified to work on it, and then be able to support it.
Yeah, it's funny. I had a conversation last week where it was a very similar conversation where he's like, we have to just scale smart, right? Not introduce so much complexity into the organization that we're growing too quickly that we can't keep up with it, but we need to control the spin of the flywheel. And so it seems like this is going to be kind of a pattern for the next couple of years. Scale, but in a smart way, and making sure that you're staying agile enough to meet the needs of your customers and their customers. Also, not get out too far in front of your skis.
Absolutely right. Because what happens, there's been a lot of just go fast, break things, build the plane as you fly it. The problem with that is you're risking your brand, and you're risking confidence of the consumer that you want to believe in you. There's been different organizations across the value chain within the EV sector, whether you look at it on the vehicle side, the charging side, the software side, and they just grow really fast, really quickly, and they're visible to the industry. And then overnight, reduction in force, cut back on costs. All it takes, you talked about technology earlier in the call. You asked me about universality and how that impacts and what are the challenges it creates or what are the opportunity it creates. Some enterprise customers that are investing in infrastructure, they're committed to deploying chargers, but then all it takes is like when Tesla opened up their network to other OEMs, it just takes that type of change in the industry to for folks that were companies that were ready to invest and buy chargers to hit the pause button and say, I'm not going to buy 100 chargers from this manufacturer because I don't know if the technology I'm buying today is going to be outdated tomorrow and is going to be what I need. And so there's all these moving pieces. And so the next thing you know, what a company forecasted for revenue is now shuttered because of a decision. Who as an asset manager wants to buy outdated product? Nobody wants that risk. And what happens is all it takes is kind of a tailwind to just some small shift and you've got all these problems. And so anyways, it's a long way of saying in this space, lots of hiring, lots of growth, move fast, break things, go. And then next thing you know, it falls apart and now people are outside of a job and the EV industry is in question is just immature.
Well, Jason, it's been a fantastic conversation. At each one of my episodes, I give all of my guests 90 seconds to plug anything that they're passionate about. So in your case, this could be for Field Advantage. This could be anything. So without further ado, the next 90 seconds are yours.
Well, again, thank you, Brian, for having me on. Look, the EV transition depends on trust. Trust comes from infrastructure that works, and that's where we come in. Field Advantage is here to make sure that we're engaged with the manufacturers of the hardware, we're engaged with the CPO, the owner operators of the hardware, and they can know that on the ground their chargers are supported and that when something goes wrong, they can call us. We're going to be there on time. We're going to fix it and get it right on the first try. We average 98% on a first time fix rate. I'm passionate about being on the front lines of emerging technology, and I work for a company that's passionate about keeping that technology operating and successful. And so we've got a proven track record. Our customers, they don't go anywhere. They stay put because they know that they can count on us to keep those chargers or all of their digitally connected assets connected and operational. And so that's what we're doing,
Awesome.
solving problems.
Jason, thank you for your time today.
Thank you.